Welcome to another IoT intro video. I'm your host, Ulno, and today we'll talk about filters in IoTempower. And of course, we need to do this a little bit hands-on, so I picked a setup for you, which I will explain to you now, and then I hope I can motivate why filters are necessary here. So you see here a capacitive soil moisture sensor. So this sensor is actually connected via a voltage divider to the A0 port here of the Wemos D1 Mini. So basically we measure voltages between 0 and 1 volt there to see then later if this is wet or not. But of course we don't know which values we actually get, so I do know if we don't use the voltage divider that we get values that are too high, so that's why I use the voltage divider to get that actually down. This device needs 5 volts, and this is why I have to protect the output and kind of take resistors to lower the value here. These are just two of the same resistors, so we basically get an output maximum from 0 to 2.5 volts, but the interesting area I know already in advance is between 0 and 1 volt. So this is pre-flashed here. This is why we power it here directly from the wall power, and then through this voltage divider we get the analog port here, which is connected here to the higher resistor, and then it falls down to ground through resistors, and this is the value we are actually measuring here. So now later we'll put this into water, and then we will see some changes to the values we have. So how do we read these values now? For this we need the analog command. So the analog command is just giving us values from the analog port, and there's only one on the Wemos D1 Mini, so we don't have to specify which one. And then later we want to use the filter, which is under F. Here, the filter. And I will explain this a little bit more. So first, let's build the program that we have and use for measuring. So we need so output is just for testing. So we need actually an analog for testing the value. And so I will just enable this here at the moment. Later we will look at the filters. So let's just look what happens if we just read analog values. Let's deploy this. So writing it over the network. And let's first see what values we are actually getting here before we switch to Node-RED. So this device is rebooting. Soon we should see a lot of the values coming up here. There we go. And you see there's actually a lot of stuff around 100 that we see here. So we can now see what's happened if we dip this into the water. So still values up to 100, and we're just plugging this in, and you see the values actually go down into the 80s. So I will just set this down here and wipe the water off a little bit. And you see we're up to 100 again. But so let's now see what that means in Node-RED actually. So let's switch to Node-RED. And here we take a graph, a chart. And we can even also take a gauge. And then we wire the values we are reading in these two. And then we want to say, okay, we are getting some values from 70 to, seems like something like 120. And we're getting a lot of values, so should make sure we just see something like the last 2 minutes. or maximum like 400 points to display in the graph. So let's see what this means. Look on the dashboard here, and you see it's kind of still a lot of stuff going on here, but we can do the water test once more. So let's put the water in. Up. And you see we had a little bit of shock there, and then the value dipped down. Let's dip it once more in. You see now you can actually totally see when I dip the water in there that it, when I dip the sensor in the water, that the graph goes down. But in total, it's kind of an annoying amount of values that we get here. So if these would be temperature values, that would be kind of way too much. So we want to actually get a couple of less values. So the easiest thing is actually just to say, let's just do that in Node-RED and do a delay node. So you can actually say, we definitely don't want more than, we do a rate limit here and say we don't want more than 50 messages per second. And so we can remove that here and put that in between. That should already help making it a little bit less crazy. So this is basically a filter applied in Node-RED. Let's see what we have now. I have to refresh that. And there we see it. And here you see actually also the gauge. So let's see, it's still a lot of stuff that comes here. So maybe let's even add one more filter on the device. So for this, I will stop the listening here. So and let's edit here our stuff. You see there are filters like, let's first look actually at the filters that are defined. Here is, if you need a generic filter, you can program this filter yourself. So you can actually here build a closure in C and kind of then get the device that we are talking about. And from the device, you can read an integer or a float, and then you can make your own statistics or own function to work on it. But there are a lot of filters predefined, and so let's just look at the predefined filters. You can do the average, but as we have seen, we get a lot of values and we don't really want to lose values. There are a lot of filters that take milliseconds as an input. So what could actually work for us is that we take a median, a running median over a specific interval. So let's enable that, and that should make things nicer. So we can actually say, let's do actually a really low poll rate of 1, but enable the poll rate. So this is actually the fluent style I use here to put this behind. And then we do a filter that only gives us something every 200 milliseconds. So basically 5 values per second. So we deploy that. And now let's check, after it is rebooted, what we get now on the dashboard. Let's refresh. And you see things are by far less crazy this time. And so let's see what happens if we dip the water in now. Dip it into the water now. See, now we see a basically instant reaction if we are inside or outside. And we also see a good cutoff value now. Let's do the same thing for the Let's leave this like this, and I will scroll a little bit down, and now you can also see this nicely on the gauge when I dip it in. See here, it goes down. So if it goes down, it is actually showing that it's wet. So let's go back. So this is kind of a nice collection of filters that we have already now here. But in the end, we want to just know if it's wet or dry. And so we have seen that the cutoff was actually somewhere around 90, where we had here the can make the decision. And maybe a little bit over 90, where we can make the distinguisher. And so there's another filter we can use for that, which is basically the binarize filter. Here, binarize, and you see that has a cutoff, and then basically we can say what is over the cutoff and what is below the cutoff. So basically what we have to do to activate that one, how do we do that? We take this here and put it over there. And so funnily, we had a little bit of trouble making this run when there were tabs in this Fluent style here. But now we just make sure that these are all real blanks and not tabs in there. And then it should actually compile. So let's also set this here to 92. And let's deploy this. And then the graph, after it is deployed, should stop, because now we just get two values that we sent there. So we'll also start a listen here, so we can see actually the values. So let's now dip it into the water and see what we will see. Oop. Something coming? No. Yes. See, wet and dry. So now it says it's dry again. And when we put it into the water, it's wet. And when we take it out, it becomes dry again. And that is exactly what we wanted to achieve. So, as you see, with these filters you can change a lot of things. You can change the poll rate, you can change the actual values and build a median, but you can also turn floating point values into binary values. So this is the way you can build some kind of cutoff type sensor. You can also use other filters like the mapping filter down here, which allows you to have ranges that are assigned to different values, and then can do something like it measures dark blue or light blue or totally white in this context. So the filters enable a lot of conversion and pre-processing of the values, and you can either do that in Node-RED or you can do it on IoTempower on the device directly. For reducing the number of values that are sent through the network, I suggest trying to do it on the device. So the more pre-processing you can do there, the less post-processing you have to do later. And this way you can do it in a very convenient way. I hope this was not too confusing. I hope you enjoyed that, and stay tuned and see you soon in the IoT Empire. Ciao.